logic gates with Boolean functions. What do you know about logic gates and Boolean functions?
They are like circuits.
They are like circuit, yes. Give me some examples to this.
NAND gate.
Yes.
I don't know about it, sir.
All right, Uday, we will learn, right? If we're going to talk about logic gates, I will get some simple example, right? If we're going to talk about this technical concept, I will explain using some simple example, right? Right? Assume that there is a door. This is a door, right? If you want to open this door, right, you have to use a key. Assume that this is some kind of a key, right? You have to put key into this hole and you will need to rotate the key if you want to open this door. Assume that there's another lock, padlock, right? So that there's a padlock here. There are two options here. One is a key, other one is a padlock. Now, if you want to open this door, right? If you want to open this door, you have to use this key and as well as the key of this padlock. Isn't it, Pudi?
Yes, sir.
Right. This is the one example, right? Both are compulsory. That means key 1 as well as key 2, both are compulsory. I will get another example, right? Assume that this is a ATM card, right? This is a ATM card. If you want to withdraw money, what are the requirements that you need to fulfill today?
PIN number.
Yes. PIN. As well as you should have a ATM card, right? You should have a ATM card as well as you should know about the PIN number, right? If you know the PIN number and if you have a ATM card, then you can withdraw money. Both are compulsory here. For this situation, both are compulsory. What is this, Pute? This is
My.
this is
It's a motherboard.
no. This is not a motherboard. This is a Pute,
Microprocessor.
a processor, central processing unit, right? This is a CPU made by the combinations of, right? Combinations of large combinations of, right? Different logic gates. There are three logic gates. Basically, we can categorize into two parts. Logic gates. One category is a basic logic gates. Right? Basic logic gate. Another one we call that the combinational logic gate. There are three basic logic gates. There are three basic logic gates. They are, first one is AND logic gate. Second one is OR logic gate. Third one is not logic gates. Right? What do you mean by combinations of logic gates? Combinations.
That means the addition of two gates.
Yes.
Two or more gates.
Yes. Right? Assume that if you use OR logic gate with not logic gate, right? NOR, right? Likewise, we can say it is a combination of logic gates. Two or more logic gates, if we can combine together, that is a combination of logic gates. We will talk later, right? We have to talk about that one also. First, we will talk about the basic logic gate. The first one is AND logic gate. And what do you mean by and now? And look at this example. If you want to open this door, you have to use the original key of this door as well as the padlock key. Here, both are compulsory. Both are compulsory. Right? Another one I will show you. Right? Right. I will take some example. Look at this one. This is a simple circuit. Right? Simple circuit board. Right? Look at this one. Right? Here, there are two switches. Switch A. Here, this is a switch A. This is a switch B. And also you can see LED bulb here. Right? This one is a LED bulb. Right? And I have a battery in this hand. You can see this is a battery. If you want to switch on this bulb, switch on, right? If I switch on this switch, can you see it? Can you
No,
see?
sir.
No. Again, I will switch off the first one. That is switch A. I will switch off. Then I will switch on the switch B. Can you see it?
No, sir.
No. Right. Now, what I do is B is switch on, and also I will try to switch on A. Now you can see the light, isn't it?
Yes, sir.
Yes. That means, Pute, both switches are compulsory to on. If you want,
That it is like the example of the door with two locks.
yes, exactly, Pute. This is similar to in this example, right? This is a simple example to explain the AND logic gates. Here there are two switches. One is A, other one is a B. Here, switch off means simply we consider it as a 0, right? If you switch off in the computer science, we say that it's a 0 state. If you switch on that one, we consider it as a 1 state, 1, 0 and 1, binary logic here, right? This is example for the AND logic gate. We will, right? First one is if you want to take some note, you can take down.
Sir, shall I take a screenshot?
Yeah, sure, Pute.
Okay, sir.
Right. Then I will explain the AND logic gate now. First one is AND logic gate. And logic gate. When you write in this word, right? Remember to write using uppercase letter. Uppercase. Right? Uppercase letter. Remember that.
Capital letter.
Capital letters, right? Just remember that.
That means we write all logic gates in capital letter.
Yes, Pute. And and not when you're writing that, remember to write using capital letters, uppercase letters, right? Just remember one, right? Right. I will draw some circuits, right? right? Assume that like this. Here I will draw this. Okay. Assume that here there is a LED bulb, right? And here you can see two batteries, and here there is two switches, right? Switch A, and there's another one, switch B. This is switch B. This is some kind of electronic circuit, simple electronic circuit. Here there are two switches. One is switch A, other one is switch B, right? This is some kind of LED bulb, right? LED, LED bulb. There are two batteries here, right? This is one kind of simple electronic circuit, right? Here, assume that now both switches are switched off state. That means A equals 0, B equals 0. Both are inputs put in. We say that inputs, right? Both are inputs. Switch A the input, switch B is also input, right? Now, if you want to get some output, what you want to do with it? Output means,
And
that means you have to switch on the bulb.
one C, one switch A, one switch B.
Right. I will that example. Yes. Here, this is A. This is B. And now, both switches are switch on. This is on. This is also switch on. That means now we are in the one is one. Both are one. Here both are 0. A and B 0. A equals 0. B equals 0. Both inputs are 0. Here both inputs are A equal 1. B also equal 1. Right? That means now you can see the bulb. Switch on the bulb. You can see a light now. Right? I explain using this one. This is the one example here. Right? This is switch A, also one state. Here, B also switch B switch also state in the one state. That means you can see the bulb light, right? Both are compulsory. That means that is an logic gate. Both are compulsory. Both are compulsory, right? Assume that state is 0. This one is 0. This one is 1. What will happen today?
Bulb will not light because
Right,
it is 0.
right. That means no. That means both switches A and B should be 1 here. Right, right. Then this is the electronic circuit when input A and B is 0. This is an electronic circuit when input A and B is 1. Right? මෙතන තියෙන්නේ බිඳුව ස්ටේට් එක වෙන එක. මෙතන තියෙන්නේ ස්ටේට් 1 එන එක. ඔයාලට පේනවා Now you can see here, you cannot see a light. Here in this example, you can see a light now. Got the point, Pute?
Yes, sir.
Right. That is electronic circuit for and logic gates. Right? Here this is A. This is B. And here I will use one battery. And here. Right? Normally we use this kind of symbol to denote a bulb. Right? We call that a Q. Normally it's the output. We denote by using Q. This is some kind of a standard, right? Q. Right? Here you cannot see a lightning because both switches are switched off. Here you can see the cross. Right? This is the electronic circuit for and logic gate. Electronic circuit for and logic gate. Table, look at this one. Here, this is input A. Assume that this is input B, right? Assume that this is a Q, that is output. Output, right? Assume that now switch A is off, right? Off. Now assume that switch B also off.
Zero.
What is the output, Pute?
Zero.
Switch on or off?
Off.
Off, right? This is one state. This is one, right? This one scenario. Next one, see, this is second scenario. Switch A is on, switch B is off. What is the result?
Off.
Off. This is a third scenario. A is off, B is on. What is the result?
Off.
Off. The final scenario, right? That is for A is on, B is on.
On.
That means switch is on, right? Here there are four situations, right? There are four occurrences here. One is A off, B off, off. Second one is A on, B off, Q off. Third one, A off, B on, Q off. Final one, A on, B on, Q also on. Right? This is AND logic gates. Here you can see to switch on the bulb, both switches should be in the on state. Isn't it?
Yes, sir.
This is the first situation, right? This is the first situation. Off, 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 right? That means off, right? Off, A also off, B also off. Second one, A is on. That means A is on, B is off. Second situation. Third situation is A is off, B is on, but you cannot see the light still, right? Final situation, that is A is on, B also on. Now you can see the bulb. It's lighting, right? Right. This is AND logic gate. Pardon me?
Okay, sir.
Right. Okay. Hurry. One of them, I will erase this one. Now. Right. Right. Computer cannot understand these words, Pute. Computer cannot understand off and on. Computer can only understand either 0 or either 1.
One.
Right? Binary logic, binary numbering system. Then off. To denote the off, we use 0, number 0. Here also number 0. Here
0.
0. We use number 1 for on state. Here 1.
1.
Here
0.
0. Here
0.
0. Here
0.
0. Here
1.
1. Here
0.
final one.
1.
Uh,
1.
1. This is called that the truth table for and logic gate. This is very important, right? Because this is truth table for and logic gate. Logic gate. This is very important, really important part, right? You have to draw this truth table. In single, we call that Satyata Agur. For the AND logic gates, you have to use 0 and 1, right? To denote some kind of instances, right? 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1. Put the topic as truth table for the AND logic gate and please draw this one. And this is a one input, that is A, right? This is a second input, that is B, right? There should be output now. This is the output. Output is Q. This is the symbol for to denote the AND logic gate, right? There are two inputs, input A and input B. There's a one output here, that is Q. Now, this is the symbol, right? Then we have to build some Boolean expressions. Boolean expression, right? The expression is Q equal, right? This is AND logic gate. This is AND logic gate. Then we have to use A and B. A and B. How to write that? Right? This is the way. A.
0 and 1.
No, we have to use this. A and B. Right? This is the standard way to write the Boolean expressions for the AND logic gate. Just remember, Q equal A. This means AND. This means AND. B. A and B. Right? We had 4 states. Can you remember, Puti? Rows හතරක් තිබ්බ නේද?
Yes, sir. 1, 0, 0, 1, 0, 0, 1, 1, 1.
All right. That means if we have 2 inputs, definitely we have 4 states, right? Then we
Yes,
can, yes, then we can build some function or formula, right? Like this. 2 to power number of inputs, right? 2 to power number of inputs. Assume that if you have 2 inputs here, 2 inputs here, that means 2. 2 to power 2 means
4.
4. This is how to calculate the how many number of states according to inputs. Right now, assume that there are three inputs here, right? Like this, I will add here. This is A, this is A, B, C, right? Now we have three inputs here, A, B, and C. How
3
many?
into 3,
2 to 3. That means how many steps put it?
6.
6. Sasil?
No, sir, 9.
8.
8 put it. 2 to power 3 means 2 by
Ah.
5. That means 8. When you are drawing truth table, you have to write 8 states now. Just remember that, right? If you have 3 inputs here, then how you can find the number of states, right? This is the some kind of formula you can use to power number of inputs. To power number of inputs. According to these situations, we had 2 inputs in the first example, 2 to power 2, that means whole state, right? If you have 3 inputs, if you have 3 inputs, 2 to power 3, that means 8 state. I will erase now. Next on, we have talked about the next logic gate. What is the next logic gate today? We have discussed about AND logic gate now. Second one is yes,
All logic gate.
OR logic gate. O logic gate. Right? This is some simple example I will take, right? Assume that, right? Assume that there's a bus, right? There's a bus now. There are 2 doors here, back and the front door, right? Assume that, right? How to get it to the bus, Pute? Either you can use back door in front of the door, isn't it?
Sir, we have to get in through the front door and get down by the back door.
Either we can use either back or front door, isn't it, Pute? Make it.
Yes, sir.
Is both are not compulsory now. අපිට එකපාරක් ඕන නම් පස්සෙන් නැගලා ඉස්සරහින් බයින්නත් පුළුවන් ඉස්සරහින් නැගලා පස්සෙන් බයින්නත් පුළුවන් හරි දෙකම කම්පල්සරි නෑ අපිට එකක් පාවිච්චි කරන්න එක්ක නැත්තම් පිටිපස්සෙන් නැග පිටිපස්ස දොරෙන් බැස්සා නේ දෙකම එක සැරේ වෙන්න ඕනි කියලා අවශ්‍යතාවයක් තියෙනවද no
No, sir.
no right this is one example right not that's another one put it right assume that right. This is your land in your home. This is your home. Assume that, right? Right. There are 2 gates in your. Assume that this is gate 1, and there's another gate in this place. Assume gate 2. To access to your home, either you can use gate 1. If it is not, you can use gate 2. Isn't it?
Yeah. Between
Right. And this one, this is A, this is B. Right? What will happen, Pute? Now, both are switch off state now. Both are switch off state now. What will happen to the bulb?
0.
This 0. That means switch bulb is switch off. Right? What happened? I will draw like this. Now, what is the state now?
1.
That means 1. That means switch on the bulb. What is the state now? What is the state?
1.
1, right? 1. That means switch on. What is the state now?
1.
1. Got the point today?
Yes, sir.
Right. Safiru, any questions for this?
No, sir.
Right, very good. Right. You can write this one like this. You can draw this one today. This is the electronic circuit when one logic or one logical state is one state, right? A is equal 1 now here, B is 0, but you can see the bulb is switch on. A, second one is B, third one is Q. Now, right? Right, before going to put a 1 and 0, before going to 1, 0, we will use O, O, right, O. Second one is on, this one is O, what is the state? On. Third state, second, third, O,
On.
on, right? Final state, that is on, right? So this one also. This is the this is the nature of the bulb of the electronic circuit for all logic gate. Nature of the bulb. Nature of the bulb of the electronic circuit for all logic gate. Look at this one. This is the electronic circuit. Now both are in the 0 state. That means off state. If I switch on A, now you can see this switch on the bulb, right? Then again I will switch off A, then switch on B. Again you can see switch on the bulb. Again I will switch off B and A. What I do is switch on A and switch on B. Same. Now you can see the switch on the bulb, right? Here again. Now you are in the this state, that is both are off. Switch A and off, switch B also off. That means bulb also off. Second one, I will switch on the switch A, right? Now you can see B is switch off state, but bulb is on. See, bulb is on. Third scenario, A is off, but B is on in this scenario. But you can see bulb is on. Now you can see bulb is on. Final scenario, that means B is on, A also on, right? Bulb also on. Now you can see the state. This is OR logic gate, right? OR logic gate. Yes, of me 0 here.
0.
0 here. 0. Second one, odd means 1, odd means 0, odd means 1, right? Here, odd means 0, odd means 1, odd means 1. Final state 1, 1. This is also 1. This is the truth table for the OR logic gate. This is very important today, right? This is important. Topic is truth table, right? I will write here. Table for OR logic gate. That is B, right? And there is an output here. the output is Q. There are two inputs, one is A, one is B. This is the shape of all logic gate. Then output will be like this. There are two inputs, right? A plus B. Previously we used
Dot B.
dot. That's for AND logic gate plus icon, plus mark icon for the OR logic gate. Here we say that A O B. A O B. Don't say that A plus B, right? Sorry. Make me this is not the plus symbol, right? A O B, right? A O B.
Sir, is it A plus B?
No. A not A plus B, right? Don't say that A plus B, right? But remember, you have to say A O B.
Okay, sir. A O B.
A O B. Don't say that this is a plus sign here. Don't say A plus B, right?
Okay, sir.
Right? ඒක කියන්න එපා මේක මේ A plus B කියලා. When you are saying it, you can say that A O B, right?
Sir, I need to write the topic and draw it now.
Yes. Draw this one. This is the symbol.
Symbols and Boolean expressions for logic.
All logic gates, right? Symbols and the Boolean expressions for the all logic gates.
Yes, sir.
When sun is rising, we have to switch off this one. Then sun is setting. That means
Auto on.
we have to on this one, right? We have to on this one. That means, right? That means this kind of one today, right? Assume that our input is A, right? Output is Q now. One scenario here, right? If A is 1, A is 1, right? A is 1, right? That means sun is rising, right? Sun is rising. Then what we have to do here today? Switch whether switch on or
Two
off.
is 0.
That means we have to switch off this one. That means Q is 0, right? Then next one, that means no sun setting. You can see sun now, right? It's a night. That means 0.
Q
Then
is 1.
now we have to switch on this bulb. That means Q is
Sir, that means in here it is like if this is this must be definitely like this.
yes today. Here you can see the input is 1, but you can see the result here. That is negative. That means here 1, here 0.
Result is negative of the
Input. Right? If you input 1, then result will be 0. If you put 0, result will be 1. This is what we call that the not logic gate, right? If you input 1, then that is negative part of, right? That means you have to put the 0. If you input 0, then your output will be 1. This is we call that the not logic gate. That is A, 0, either 1 or 0. If you input 1, then result will be 0. If you input 0, the result will be 1, right? This is the symbol for the not logic gate. I will draw this one, right? This is the not logic gate.
then
The input A, then this is the symbol. See the icon here, okay? See the icon, and this is the output Q, right? If you input A, you have to get the negative of that one. We can denote using this mark, right? This is A input, this is the symbol. Like this, you have got Q equal A negative, right? Like this, right? This is the Boolean expressions and the symbol for the not logic gate. This is the truth table for the not logic gate.
Sir, what is the Boolean expression? It is not clear.
This
Q
one
equals
A, this is A. Here we say that this line, dash line for the
A dash.
yes,
Okay, sir.
for to denote the not. One is B. Then there is a output called that the P. Right? In here, again you can see another AND, right? And logic gate. Again, there's another input into this one, called that is C. Right? Then here you can see the output called that the Q here. Q. So, all right. Here, this is an and logic gate. Here you can see there are two inputs. One is A and B. The output will be P. And there is another AND logic gate, right? The inputs are P and C. P and C. The output will be Q. The output will be Q. The first question is write down the P. That means this one. P, which is output of the AND logic gate. This is the AND logic gate for A and B inputs. That means P equal A and B. A and B. Right? That is the first answer for the first question. P equal A and P. Right? A and P. Second one is write down the Q. That means this one. Right? Q equal, that means P and C. P and P and C. P and C. That is Q. If it is not, you can write this way also. That is Q equals, here the output is A and B. A and B. Again you can see here. See here. That means again AND logic gate. That means see Q equal A and B and C. Right? If it is not, you can see here Q equal P and C. P and C. Right? Next question is how many status put here? How many outputs will be here? There are three inputs here. One is A, B, and C. Then tell me how many outputs how many? 8, right? How you can say that? 2 to power 3. 2 to power 3 means 8. When you are writing truth table, you have to write 8 state, right? You have write 8 state, right? We will write it next. So Sharon, innoned. මේක හරියනේද සසරු? සසරු මේක හරියනේද? All right. Then I will draw the truth table.
Sir, is that the first exercise you gave?
Yes, Uday. Now I am
Okay, sir, I'll see to the recording.
okay with it. Next one, I will draw the truth table. Right. Then here, right? One is A, one input is A, other one is B. Then there's another one we call it C. First we have to get the A and B, right? That means P equal A and B, right? I will write A and B. Then finally you have to get the A and B and C, right? Q equal A and B and C, right here. A and B and C, right? That is Q equal, right? P equal, right? First one, right? First state today. What is the first state? A is 0, B is 0, C is 0. Tell me now, what is the A and B? Yes, Sasiru? Shiro?
And B,
A and B, what will be the
0.
0, right? Then tell me the A and B and C now. That means you can compare this one. Here A and B here, C is here. What is the result?
0.
0. Next one, right? I will write this one. A is 0, B is 0, Z is 1. What will happen today? Now, A and B, compare this one. A and B, both are 0 today. 0, 0. What will be the result here?
0.
Again,
0.
0, right? Here we have to get the A and B.
Yes, sir, 0.
0, right? Now 0. Next one, A and B and 0. Here, look at this one. That means we have compared this one. A and B is 0. Z is 1. What is the result today?
1.
1. Sharon said 0 today. Right? 0. Both are should be 1. Right? If you want to get the 1, both are should be 1 today. Can you remember? This is an AND logic gate. And this is the AND. Next one, let's see. Right? A is 0, B is 1, Z is 0. Right? A is 0, B is 1, C is 0. What will be the result here? A and B, that means
0,
0. Then tell me the A and B and C now. Compare this one. A and B, this column, and this one, C is 0. A and B is 0. Z is also 0. What will be the result for it?
0.
0. Next one, next state. 0, 1, 1. Correct? 0, A is 0, B is 1, C is 1. Right? Then tell me A and B now. Now A is 0, B is 1. What will be the result?
0,
0. Now, see, A and B and C, compare this one. A and B is 0, C is 1. What is the result for it?
0,
0. Right? Now we have completed 4 state. We have to complete another 4 state now, right? Next one, I will say A is 1, B is 0, Z is 0. Sorry. A is 1, B is 0, C is 0. Now tell me A and B. A and B. A is 1,
0,
0. Then tell me,
0.
right. A and B, A and B and C. What is the state now? Compare this one. 0 and
0.
0.
0.
Right. Next one, today. Right. I will say that A is 1, B is 0, Z is 1. This kind of one. You cannot see? Yes, you can. This one. A is 1, B is 0, Z is 1. What will be the result here? A and B?
0,
0. What will be the A and B and C? This one today.
0,
0. Right? Next one. I will say that A is 1, B is 1, Z is 0. Now tell me the A and B. Now,
1,
yes, Aaron? A and B, what will be the result? 1. Why? Both are 1. Both are 1. Right? Then tell me A and B and C. What is the result today?
0,
0. Right? Here A and B is 1, C is 0. Right? Therefore, result will be 0. Final one. Right? A is 1, B is 1, C also 1. Right? Here, tell me
B1.
A and B, 1. Then A and
1.
B, C is this one.
1.
That means this one. This is the state of the AND logic gate according to our questions.